Hello and welcome to our SOL review of A.04c, Solving and Graphing Quadratics. Now if you notice I have four little buzzwords here. I have zeros, roots, x-intercepts, and solution. These are all words that refer to what we're actually getting at the heart of, which is on a graph it would be the x-intercepts where it passes through, or you could think of it as the y value being 0. Take a look here at this first problem I have though. We'll get to the graph in a second. If you notice, it's equal to 0. Hence why we call it a 0. That is vital to solving any type of quadratic. It must equal 0. If it doesn't, you have to do a little bit of work beforehand, and in our example problem, we'll actually see what that's going to look like. So we'll get there in a minute, though. Don't want to race ahead of myself. So what we need to do is we're actually going to do what we were doing back in A.2c. We're going to factor this polynomial. So I'm looking for two binomials, and I'm going to leave that equals 0 part. Now, I need the factors of 12. Well, for 12, I'm going to put a little scratch section here. For 12, there's not too many. There's 1 and 12. There's 2 and 6, and there's 3 and 4. Now, we need the combination that's going to either add or subtract to, well, in this case, -1. That's either going to give us 13 or 11. I'm just adding or subtracting them together. That's going to give us 8 or 4, and this will give us 7 or 1. Oh, so that's the combination we need with a 3 and with a 4. When we multiply them together, it needs to be -12. So that means one of these is positive, the other one's negative. And if you notice, when they add together, we have to get -1. Well, for that reason, we need to make the 4 negative, so that way there's more negatives than positives. If I was factoring, I'd be done, and I could just go on with my life. But since I'm trying to actually solve it, I need to find these zeros, or roots is really the way this is going to be described in this context. So here's what you do to take a little bit step further. We're actually going to separate this into two problems. We're going to do x plus 3 equals, and you remember I said it had to be equal to 0. Well, we're going to set both of these binomials equal to 0. The reason we're doing that is when we look at the graph, wherever it touches the x-intercept, the y value, which sometimes this is also labeled as y, has to be 0. When you're on the x-axis, you didn't go up, you didn't go down, you're stuck right there. So that's why we set the y equal to 0. It's because it'll find out which x values would work. So over here we have x plus 3 equals 0. That's pretty easy. Just go ahead and subtract 3 from both sides. So x equals -3. That's one of our roots. And then over here, to get rid of -4, we would just add 4, and that would give us x equals 4. Cool. So that's how you would do it algebraically. How you would do it graphically is a little bit different. So again, I've kind of pointed this out a little bit, and it might make a little more sense talking about it now. But if you look, this graph touches the x-intercept, or the x-axis, twice. Those are the two roots right there. So we can just kind of label them. So this would be -1, and this would be 1, 2, 3. So those are our two roots in this problem. Let's go ahead and take a look at an SOL problem. All right. What values of x are solutions of 3x squared plus 11x equals 20? Now, I made a big point of it earlier, and I got to keep stressing it. This has to equal 20, and if you notice, this does, or it has to equal 0. But it equals 20. See, that's a problem. We need this to be 0. Now, I could get rid of 3x squared, and I could get rid of 11x. I could subtract both of them from the other side, but why move two terms when I can just move one? So what I'm going to do is subtract 20 from this side, and then draw my little equals divider. But there's no other just number over here. This is x squared, and that's x, and it's just a number. So what's going to really happen is it just kind of wedges itself in there. So this becomes 3x squared plus 11x minus 20 equals 0. So that's where we're at now. So then you're going to do the same process we did before. We're going to go ahead and we're going to try to find these two binomials. Now, because of the 3 in front, it's not going to be like the other problem we did where it was x and x. Since 3 is prime, one of these has to be 3x, and the other one just has to be x. And again, think about when you distribute it out. 3 times 1 is 3, and x times x is x squared. Now, I'm going to go ahead and put the equals 0 back up. We need factors of 20, so do a little side note so that way we don't consider those numbers part of the problem. So the factors of 20, we got 1 and 20, we've got 2 and 10, and we've got 4 and 5. So those are the multiplication numbers, but here's where it gets tricky. You got to remember from 8.2c factoring, one of these numbers is getting multiplied by 3, and we need this to work out to be positive 11. So you've got to just keep that in mind, like, hey, one of these numbers is going to get multiplied by 3. So if we did 1 times 3 and add or subtract it to 20, that's either 23 or 17. So that doesn't exactly cut it with what we need. If we did, let's see, 3 times 2, well, that would be 6. 6 plus 10 is, no, it's 16. And 10 minus 6 would be 4. Neither of those 11. So let's do 3 times 4. That's 12. 12 plus 5 is 17. It's too big. And 12 minus 5 is 7. That didn't really work either. Well, let's try 3 times 5. So again, we're just kind of trying to see which number multiplied by 3 makes these work. 3 times 5, that's 15. 15 plus 4 is 19. Now, 15 minus 4 is 11. That's what we needed. Awesome. So we're going to go ahead and multiply 3 by 5. And you might be saying to yourself, whoa, why didn't you put it over there with the 3? Well, just think about, and I'm kind of jumping ahead a little bit, but when we do distributing in this section, the number in here is never going to get multiplied to the 3. So when we distribute, 3 is going to get multiplied to the number over there, which is 5. So this was 5, this was 4. Now the last part we have to do is we have to figure out which sign is which. Well, they multiply to a negative. So one's positive, one's negative. But we need more positives than negative when we add them. So that means this is going to be 5 and this will be 4. Now would be a really good time before you go to the next step to just distribute it out. You know, do the other, clean this up, distribute this as well. Make sure that everything is, you set up the binomials right. You should get 3x squared plus 11x minus 20 if you did it correctly. But we can go ahead and assume I've done it correctly this time. Now we split it apart and we set each side equal to 0. So we're going to have 3x minus 4 equals 0. We're going to have x plus 5 equals 0. I'm going to clean up the easier one. So minus 5 from both sides. So one of our roots is negative 5. So if the problem doesn't have negative 5, we're done. And actually, our answer should be D. But just because I like confirming things, if I add 4 to both sides, 3x equals 4. Divide by 3. And yes, x equals 4/3. Thanks for watching.